We are going to go over particle motion in tutorials today. I stole this from the AP Summit, so if you have been to that already, go ahead, you can skip forward and just work on practice and the free response that I post on here for you guys. Key thing, remember, derivatives go down our list, position becomes velocity, becomes acceleration. This is our derivatives. Then over here, as I take my integrals, I go from acceleration to velocity to position. So, quick review. X of t, that is our position. So initially is always when our time is 0. Origin means, oh, we're starting at a y value of 0. So that could be at any time, but we have a y value of 0. And then at rest means that our velocity is 0. So if I want to find that because they gave me our position, I would have to take a derivative to get here. So, derivative of x of t. Now, if the velocity is positive, it's moving to the right. Negative, it's moving to the left. So this is really important because they'll ask questions about this on free response. They'll say, hey, what intervals is it moving left? And you would have to say, okay, I know that means my velocity is going to be less than 0. You would draw your little thing, find your critical points, and be like, oh, if it's negative here, positive here, so this is at 0. You would say, oh, on this side of my graph. Now, average velocity, that's going to say, hey, x of b minus x of a over b minus a. So we say, okay, what is our final minus initial position? Because we're finding our slope to find our velocity. Or, remember, that's going to be equal to the integral from a to b of v of t over b minus a. Next thing, instantaneous velocity. Remember, that's still just our derivative here. We're saying, what is it at that exact moment, meaning I need a slope of a curve, derivative. Acceleration is positive. Velocity is positive. Oh, sorry, thing in the wrong one. Acceleration is positive. That means our velocity is increasing. Acceleration is negative. The velocity is decreasing. Now, change of direction. Velocity changes sign. So, changes positive to negative. The one we have to be careful with is the speed, because then we need to look at both the acceleration and the velocity. Okay, do they have the same sign or do they have opposite signs? So positive and increasing, negative and decreasing. Okay. Last thing, if it's decreasing, okay, these are going to have opposite signs. So one's positive and decreasing, one is negative and increasing. The last part at the bottom here. It doesn't want to show it on the thing. There we go. Lots of information. Go ahead and flip this to the next page if you printed it out. So our model free response here, it says, hey, we're going from 0 to 6. The particle's moving along the x-axis. We know the particle's position, x of t, is not explicitly given. But we know what v of t is. It's this function right here. So the acceleration of the particle is then given by this function. We also know our initial value, x of 0 equals 2. So the speed of the particle increasing or decreasing at time t equals 5.5. So give a reason for your answer. What you would need to do here is you would say, okay, speed is increasing or decreasing, increasing. That would mean I have same sign. Decreasing would mean I have opposite signs. So what I need to do is say, okay, well, what is v of 5.5? And what is a of 5.5? So you go ahead and plug those in. Once you knew that, you would say, okay, it is blank because blank. And you would either put opposite or same here, sign for velocity and acceleration. Now, it says find the average velocity of the particle for the time period 0 to 6. So that's going to be our A and B here. Average velocity, whenever you see average, think the integral from A to B of that function divided by B minus A. Or think of x of B minus x of A all over B minus A. Depends on what they give you. For this one, they give us velocity, so we're going to be right here. So you're going to say, hey, what is the integral from 0 to 6 of v of t dt all over 6. So, still technically equal, you're still finding x of b minus x of a because of our fundamental theorem. You're still dividing by b minus a, 6. So, what we would do here is you would just plug that into your calculator and find your value. That will be your average velocity. For C, find the total distance traveled by the particle from time t equals 0 to t equals 6. So total distance, that tells me absolute value. So when I find the absolute value of v of t dt, my integral from A to B. Because we're not doing displacement, we have to consider, okay, my negative area, I'm counting that now. So the way we'll set up our integral, lower bound 0, all the way up to 6. Absolute value, v of t dt. So we can see that on our calculators. So what you'll do is you'll find that 0 on your graph. Got some sort of sine function. We would say, okay, where is this 0? I'm going to call it A. Anywhere this is negative here, I'm going to say, okay, well now this is going to be the integral from 0 to A of v of t dt. And to cancel out that negative area, I'm going to say minus the integral from A to 6 of v of t dt. If it were to cross multiple times, you would just keep going. You would say, okay, well now I'm adding on here at B, so you would be plus the integral from from B to, say this was finally our 6, B to 6. For D, now we want to know that the particle changes direction exactly once. It says, hey, find the position of the particle at that time. So what you need to do is say, okay, if it's changing direction, that means the velocity changes from positive to negative, or it changes from negative to positive. So first off, find a point on your graph where you have a 0 for v of t. Once you know what that t value is, what you can do is, if you want the position, think about your fundamental theorem here. F of b is equal to f of a plus the integral from a to b of f prime of t dt. So in this case, f prime, that's going to be our velocity function. F of a here, that's our initial point, which we know it was, where'd it go? I lost it. Oh, x of 0 equals 2. So if I know x of 0 equals 2, then I know that my setup for this is going to look like, okay, v of whatever value I have here, we're going to call it b. It's going to be equal to a2 plus the integral from 0 to b of v of t dt, which once again, you can just type all of this into your calculator, get a value back out. So, if you have any questions here, feel free to email me. After this, there is a bunch of multiple choice practice. I'm going to post this document online, and I'll have an answer key available if you guys would like one, or you can ask your friends that were at the summit. I'm guessing they went over it there. So here's all the questions. It looks like there's, I think, 4 multiple choice and a practice free response. So that document will be on the website. And then I also have another free response here. It's similar to ones we practiced in class. This is from 2017 though, so a little bit newer question. It says, if I had 2 particles this time though, moving along the x-axis, for 0 to 8, the position of particle p at time t is given by this function. So this time they're giving us a position function. That's for particle p. Now, while the velocity of particle q at time t is given this. So this one is velocity for q. It also tells us the position for q at time 0. So initial position here. So we know the point 0, 5, and that's for particle q. So they want to know when particle p is moving to the left, key thing, velocity, well, that means it needs to be less than 0. So you're going to find where your velocity equals 0, then do your number line. So if these are just hints, if you need them to get started on it, if you feel confident trying it on your own, go ahead and do that. I forgot to mention it at the start. 4b, 0 to 8, find all times t which the 2 particles travel in the same direction. So we need to figure out, okay, where are they traveling in the same direction? So once again, you're going to use that number line you made up here, and this is for particle p. And then you're going to actually make one for q as well. You're going to say, hey, where did this one change direction? Where do they have overlapping positive and negative signs? So that say this was at 1 and 2, positive, negative, negative here. This is not remotely accurate for the problem. But say this one only changed once at 1.5 and it was positive here, negative here. Well, there would be an overlap portion here. Okay. Well, these are actually both positive here, so they'd be going the same direction then. And they're both negative here. So I would say, oh, they go in the same direction from 1 to 1.5 and from 2 onward. For C, we're finding the acceleration of particle q at time t equals 2. They already gave me velocity, so I'm just saying, hey, what's v prime of t? And then we are evaluating that at t equals 2. Now it says, is the speed of particle q increasing, decreasing, or neither at 2 then? So now they already gave me some of the steps to help me with this. They said, hey, we've already found what our acceleration is. Is your acceleration greater than 0? Is your acceleration less than 0? And then you're going to compare that to the velocity. Is my velocity greater than 0, or is my velocity less than 0? So depending on what your pairs are, you're going to say increasing or decreasing. Increasing, same sign. Decreasing, opposite signs. D, last one, find the position of particle q the first time it changes direction. So remember, changes direction is when your velocity changes from positive to negative, meaning it has to go through zeros. So it's your first one, closest to 0 for your x values. If we are finding position though, for q they gave us velocity, meaning I have to do an integral of v of t dt. You're actually going to use your fundamental theorem. So once again, you're going to say plus, x of 0 from 0 to whatever value. It changes direction first. I'm going to label that b. That will equal that x of b here. Do not forget to add in that initial value. So I am going to collect these probably on Monday next week. So Monday, for anyone who has mandatory tutorials. Once again, questions, email me. I think I went through pretty good with that. So try it on your own. If you're super stuck, then email me or talk to someone. All the things. I believe in you.